Look back far enough into deep time, and our planet looks less like a sanctuary and more like a hostile, churning engine. Earth's default operational state is violent, routinely scrubbing its biosphere clean and restarting with new players. These planetary resets are driven by specific physical mechanisms: advancing ice ages that bury continents under miles of ice, supervolcanic eruptions that blanket the sky in ash, or subtle shifts in orbital mechanics that collapse food chains for millennia. We can see the literal scars of these resets in the geological record. This is a dark band of iridium-rich clay separating two distinct rock layers. Below it, dinosaurs flourished. Above it, they are entirely absent, proof of a sudden planetary interruption. The evolution of complex life past simple slime depends on the rare Earth hypothesis. This framework argues that Earth's history is a highly improbable run of luck, requiring a stable star and a rocky planet with the perfect chemical composition to avoid a permanent reset. Human civilization exists as an anomaly within this system. We are thriving only because we happen to live in a brief, quiet window between Earth's natural reset events. Yet modern civilization operates on a paradox. We are running an economic model of infinite resource extraction on a system that is mathematically finite and historically unstable. The impending ecological bottleneck we face is a critical systems engineering failure. We are attempting to run heavy industrial processes on hardware that was never designed for this much load. To navigate this bottleneck, we use a framework called the planetary stack. Layer 1, bedrock astrophysics and hardware. Layer 2, the biological operating system. Layer 3, the information age data network. And Layer 4, the human cognitive interface. Averting systemic collapse requires a simultaneous upgrade across all 4 of these layers. Because they are interdependent, attempting to fix the energy grid while ignoring human psychology ensures the entire stack eventually fails. Layer 1 is the hardware. Our planet's basic habitability relies on extreme physical contingencies that occurred billions of years ago. Early in Earth's formation, a Mars-sized body named Theia collided with the young planet. That impact restructured our planet's interior, leaving us with a dense, solid inner core and a swirling liquid outer core. This swirling liquid core acts as a dynamo, generating a powerful magnetic field. This magnetosphere serves as a shield, deflecting the solar radiation that would otherwise strip away our atmosphere, as happened to Mars. The debris from this same collision coalesced to form our abnormally large moon. The moon's gravitational pull locked Earth's axial tilt in place. Without this stabilization, our planet would experience extreme climate swings that would erase complex life before evolution could adapt. This hardware also includes plate tectonics, which functions as the planet's internal thermostat. By recycling carbon dioxide into the atmosphere, these shifting plates regulate long-term surface temperatures. Earth's hardware is an irreproducible cosmic accident. It is a closed system that humanity cannot remanufacture if we push it beyond the breaking point. We have now moved into Layer 2, the biological operating system. The scale of human activity has reached a point where we have fundamentally modified how this system functioning. This reality led the Ecological Society of America to adopt a new paradigm for a crowded planet. Their focus has shifted from passive observation to making ecologically informed decisions. Studying pristine, untouched wilderness is no longer the primary goal of ecological science. In the 21st century, there is virtually no ecosystem left that isn't shaped by human intervention. The new mandate for ecology is active management. We must now engineer ecosystems to balance human consumption with the preservation of vital services like water filtration and crop pollination.
We have left the era of passive conservation. Survival on a crowded planet now requires active, calculated ecological engineering. To manage that operating system, we need Layer 3, the data network. You cannot regulate, price, or stop a pollutant if you have no way to accurately measure it. The NYU Law Review identifies these information gaps and uncertainties as the core reason environmental policy often fails. If we can't see the problem, we can't design an institutional response. Information age tools are closing these gaps. Remote sensing and distributed data networks are collapsing the cost of acquiring environmental data, allowing us to track resource consumption in real time. This data enables new institutional solutions, ranging from precise command and control regulations to the establishment of robust environmental property rights. For example, interactive emissions scorecards put local pollution data directly into the hands of the public. This accessibility empowers communities to hold local polluters accountable through social and economic pressure. While this digital network provides the planet with a sensory nervous system, the data itself is useless if the human operators choose to ignore what it's telling us. This brings us to the final bottleneck. If we have the ecological frameworks and the data networks, why is the global turnaround still stalling? The Club of Rome identifies this as a failure to address the inner dimension. They argue that material policy levers won't move unless we reckon with the collective structures of thought beneath them. Our current mindset is still shaped by an Enlightenment-era perspective that treats humans as separate from nature. This worldview, which reduces complex systems to simple resources for exploitation, acts as corrupted foundational code. We must upgrade our inner cognitive frameworks, our worldviews, mindsets, and values, to overcome the psychological barriers to collective action. Global faith networks are one of the most efficient mechanisms for updating these values at scale. By citing scriptures and the behavior of saints, religious leaders are leveraging immense social capital to fight environmental apathy, aligning ethical stewardship with climate justice. Structural policy will always fail unless it is tightly integrated with the psychological and cultural values of the society enacting it. The outer dimension depends entirely on the inner. Integrating all 4 layers of the planetary stack allows us to evaluate the Earth for All Survival Guide and its 5 extraordinary turnarounds. There is a dynamic interdependence. External material levers, like energy grids, connect to internal human capacities. Pulling a policy lever on the left triggers an immediate reaction in the cognitive nodes on the right. You cannot transform the food system without transforming the human value system. Earth is not fighting humanity. It is an impartial system simply responding to our inputs, just as it has responded to volcanic eruptions and asteroid strikes for billions of years. Avoiding societal collapse requires our psychological development to match the complexity of our planetary resource management. Compared to the deep timescale and cosmic violence of Earth's history, our modern technological civilization is incredibly fragile and temporary. The cosmic luck that gave us a magnetic shield and a stabilizing moon cannot protect us from a biosphere reset that we induce ourselves. This environmental bottleneck tests whether human intelligence and cooperation can successfully stabilize a system this complex. History at this scale is rarely changed by a single event. It changes through the millions of quiet, ordinary decisions made by individuals every single day. Earth is the only known place in the universe to have imagined us back. Ensuring its story continues is now our exclusive responsibility.
Please subscribe my channel for more informative video like this.